Chapter 5, Nuclear Chemistry. So this is the chapter where we're going to talk about changes that happen deep in the nucleus. These are not electrons being lost and gained, which are common occurrences. This is changes deep within the nucleus of the atom and happens much more rarely, more exotic chemistry. So what is a radioisotope? It's an isotope of an element that emits radiation because it's unstable. And it's usually written with a mass number. So you'll see C14, which is carbon 14, or maybe iodine 131, which is used as a treatment for hyperthyroidism. There are several types of radiation that can be emitted. So the first is an alpha particle. And the symbol is an alpha, or we can put the mass number and 2. An alpha particle is composed of two protons and 2 neutrons, but no electrons. So it has a mass of 4, because it's got two protons and 2 neutrons, and a charge of plus 2, because it has those 2 protons. The required shielding to protect yourself from alpha radiation is very slight. A piece of paper will do fine. What you want to make sure is that you don't ingest it. It is can be very harmful radiation if taken internally. Beta particles are next. Beta particles are just kind of think of them as a souped up electron. They have a mass of 0, because we don't count the mass of an electron because electrons are so light. It has a charge of -1. And you can be protected from beta radiation by heavy clothing. And gloves. Okay. A positron can be thought of as a positive electron. It again has a negligible mass. I'm putting 0 here, but it's just very small, and a charge of +1. Gamma radiation is symbolized by gamma. It has no mass and no charge. Therefore, it's very difficult to stop. And gamma radiation requires lead or concrete to stop it. A positron is a proton, is a proton, a helium nucleus, has a mass of 1 and a charge of 1. The helium nucleus with no electrons. And a neutron has a mass of 1 but no charge. Okay, so those are the types of particles that are released during by radioactive compounds. So what happens during radioactive decay is that an unstable nucleus emits radiation to become more stable. And we'll be writing these nuclear reactions. An important point in writing them is that the sum of the mass numbers and the sum of the atomic numbers on one side of the arrow will equal the sum of the mass numbers and the sum of the atomic numbers on the other. There are 5 steps to writing a complete nuclear reaction. You'll write the incomplete nuclear reaction, write everything you do know. Determine the missing mass numbers, determine the missing atomic numbers, determine the symbol of the new nucleus, and complete the nuclear reaction. So that's kind of esoteric. Let's look and see this problem. Write a balanced nuclear reaction for the alpha decay of the following. So this is a polonium 208,